So example 3 says evaluating a function. We want to find the values of the function, f of x, when x is equal to -1, 0, and 2. And then we want to determine whether or not f is 1 to 1. Well, because we have such a strong knowledge of what these graphs look like, we can go right to that green answer and we can say, well, this is a quadratic. This is going to fail the horizontal line test. This is a parabola that opens up. It's going to easily fail in every situation except for when that horizontal line is on the vertex of the parabola. Therefore, this is not 1 to 1. But the first part of the problem says, let's evaluate. Let's find when x is -1, let's find when x is 0, and let's find when x is 2. So let's answer that question first. When x is -1, I do the -1 squared in my head, and I get 2 plus 4 is 6, 6 plus 1 is 7. So mainly I just want to show you what I do in my head. I just square that number in my head. When I put a 0 in, I don't show any work. That's a 1. And when I put a 2 in, 2 times 4 is 8. -4 times 2 is -8, and then plus 1. So that answer is also 1. Now what they're trying to get at here is they picked values that would lead you to discover that I have two outputs that are the same with different inputs. Therefore, this is not 1 to 1. But we knew that it was not 1 to 1 because we know what this graph looks like. Okay, you go ahead and try here. You probably already know the answer on whether or not this function is 1 to 1, but let's find the value of f of 0, f of 1, and f of 4. Okay, f of 0 I have is 1, f of 1 is -3, and f of 4 is also -3. The y's repeat, therefore we know that this is not 1 to 1. I'm going to go back up here and I'm just going to write that right here. Not 1 to 1. Just in case someone was watching and didn't have the sound on. Sometimes that happens when you're watching my videos. Now the next videos, I am not going to fib. They are fantastic. Now is when the algebra really starts getting good.